All right, this is 14.7 for Math 102, and I'm going to finish up the distance and rate times time problems. So the first thing that we need to remember is that distance equals rate times time, and then we need to solve for time in terms of distance and rate, and time is going to be distance divided by rate, and that's going to be important, okay? So a couple things that we're going to be looking at is when they say in the same amount of time. So here we see the same length of time. That means that our times are going to be equal, okay? But we are going to use our table and set up. We have two people that are traveling, Beth and Anna. So we're going to make a table where we have Beth in one row and Anna in another. And then we have our distance, we have our rate, and we have our time. Now remember, the variable usually always comes into play when it's talking about the rate. So now I'm going to fill in the information that I know. It says Beth travels 208 miles, Anna travels 192 miles, and it says Beth's speed is 4 miles greater than Anna. So usually the one that is mentioned second, that's how I'm going to define my single variable. So Anna is going at R miles per hour, and Beth is going 4 miles faster. And so now I have to take my time and solve my time in terms of distance and rate. So Beth's time is 208 miles divided by R plus 4, and Anna's time is 192 miles divided by R. And since these are equal, the same length of time, I'm going to set Beth's time equal to Anna's time. So 208 over R plus 4 is equal to 192 over R. This is a proportion, so I can cross multiply. So I'm going to take 208 times R and 192 times R plus 4 on the other diagonal. Go ahead and distribute on the right-hand side, so I get 192R plus 768, and then I'm going to subtract 192R, and I get 16R is equal to 768, and then I divide by 16, and so I am going to get R is going to be 48 miles per hour. And that's Anna's speed. So you're going to have a box for Anna's speed, and she's going 48 miles per hour. And then Beth is going 4 miles faster than Anna. So she is going 52 miles per hour. Okay? All right, so the same idea is going to come across for this next problem. This time we have a commercial airliner and we have a private plane. So we're going to set up our table so that we have commercial in one row and private in another. And then we've got our distance, our rate, and our time. And says the commercial airliner goes 750 miles in the same amount of time, so that's going to be important, that it takes the private plane to travel 300 miles, and the speed of the airliner is 60 miles more than twice the speed of the private plane. So we're going to have the private plane be R, and then the commercial is going 2R plus 60. So now we take our time as defined as the distance divided by the rate, and the distance divided by the rate. And since it says same amount of time, we're going to set these two times equal to each other. So I get this. Now I'm going to cross multiply 750 times r, and then 300 times 2r plus 60. Distribute so that I get 600r plus 18,000 equals 750r. Subtract the 600. So I get 150r is equal to 18,000. And then I'm going to divide by 150. And that says that the private jet, which we defined as R, is going 120 miles per hour. So the private, and you'll have two boxes in your Hawks, private plane. And so that we're going to fill in with 120. And then the commercial, we have to figure out by taking 2 times 120 and then adding 60. And so that is going to give us 300 miles per hour. And that's what I would fill in for the other blank. Okay, so that's one specific type of problem that you'll have. Now, the other type of problem, we are going to have a little bit different setup. So when we have this different setup, we're still going to have our rate is going to be still defined, where the variable comes into play, and our time is going to still be our distance divided by rate. But it's the type of equation that's going to be set up a little bit differently. So Jen is riding her bike to her friend's house. So let's go ahead and make our column 2, and then it says on her way there, and then it says on her way home. So to and from her friend's house. And so we have distance, we have rate, and we have time, okay? So it says that she rode the distance, and each way is going to be the same distance. She rides 4 miles there and 4 miles back, okay? It says on her way to her friend's house, her speed was 15 miles faster than on her way home. So on her way home is R, and on her way to her friend's house is R plus 15. So my time is 4 over R plus 15 and 4 over R. Now this doesn't say it takes the same time. So now we have to look and says, well, she spent a total of 1 hour riding. So her time to her friend's house plus her time from her friend's house equals 1 hour. So now we're going to replace. Time to was 4 over R plus 15. Her time from was 4 over R, and that equals 1. And so this is a rational equation, which we don't have a proportion, and we can't cross multiply, but we have to eliminate the denominator by using the LCD. So my LCD is going to be R times R plus 15. So I'm going to multiply each one of these terms by R times R plus 15 times R plus 15. So what happens, remember, is that this denominator cancels this, and so now I get 4R. This R cancels this R, and so I get 4R plus 15 in parentheses, and then 1 times R plus 15, I just get that. So now I've got a lot of cleaning up to do. So 4R plus 4R plus 60 is equal to R squared plus 15r. Go ahead and combine my like terms. So I get 8r plus 60 is r squared plus 15r. And now I've got a quadratic equation. And so this quadratic equation, I got to set it equal to 0. Since my r squared is already positive, I'm going to subtract 8r and I'm going to subtract 60. And so that gives me, I'm going to come over here, r squared, oops, that's a little wonky. So let's make that r squared. 15r minus 8r becomes 7r minus 60 is equal to 0. And it's a quadratic equation, so I have to factor it. So I'm looking for factors of negative 60 that make positive 7. So that would be positive 12 and negative 5. Then I set those factors equal to 0. So r is negative 12 or r is 5. And of course, we cannot have a negative speed. So going from her friend's house, she was riding 5 miles per hour. And going to her friend's house, she was riding 5 plus 15 or 20 miles per hour. Okay? All right, so now let's look at this next one. And this next one, we again have the same length of time. And this will be the last one that we do. This same length of time, but you have to remember your rates. So let's write this. Our rates are always going to be the man-made vehicle. So in this case, it's a boat. Plus or minus, depending on the direction that you're moving, the natural force, which is going to be either wind, current, whatever, that's going to be slowing you down, okay? So we have the boat traveling with the current in the same length of time that it travels against the current. So we're going to say with the current is going to be my first row, and against is going to be my second row. We have distance, we have our rate, and we have our time. So it says the boat travels 40 miles per hour in still water. That's going to come into play in the rate. It says it travels 126 miles with the current, and it travels 114 miles against the current. So the boat speed is 40 miles, and if it's going with the current, we're going to add it, okay? And I'm just going to call C, let C equal the speed of the current. And if we're going against the current, you take the speed of the boat and you take away the speed of the current. So the time is going to be 126, the distance, over the rate. And then against, it's going to be the distance over the rate. And so since it says, where is it? Here we go. Same length of time. We're going to set these two equal to each other. So 126 over 40 plus C is equal to 114 over 40 minus C. So we cross multiply, and we get this. 126 times 40 minus C is equal to 114 times 40 plus C. So now when I distribute, I get 5,040 minus 126C, and I get 4,560 plus 114C. I'm going to add 126C to both sides, and I'm going to subtract 4,560. So I get 480 on this side. This goes to 0. This goes to 0. And I get 240C. Divide by 240. And so the speed of the current is 2 miles per hour. And that finishes up 14.7, the distance equals rate times time problems.